Hey, good morning, ladies and gentlemen. Hey, this is the answers to the Conceptual Physics 2.7 quiz review. Okay, so on Friday the 21st, you guys are going to have available to you to start that 2.7 quiz. Now remember, don't start it until you're ready because you only have 1 hour, and you can start it and finish it up until Sunday night at 11:59. So if you waited till the end, that would be presumably at 10:59, and that would give you an hour until 11:59. So you want to make sure you do that. And you want to have all of your notes, So you want to, if you have not done so already, you want to take notes on all the stuff that we've talked about, like the observations and interpretations and the claim evidence reasoning, which we'll talk about, the scalars and vectors, the distance displacement, speed and velocity, which we'll go over in a little more greater detail. The Sultan, which is on graphing, which I'm going to talk a little bit more about the graphing here in my examples. And then on this quiz, there's going to be like 6 or 7, 8 maybe questions that are going to have to do with calculations. So make sure that you have got a calculator when you're ready to go. Now, some of these questions that are in the review are going to be similar to the ones on the quiz, and I'm going to go through those types of problems, the ones that you see on the review. So if you're starting this webcast and you have not, if you've not done the review, I would stop now and go back and print that out and try the quiz. Try the quiz first. Okay. All right. So even though we are getting to these questions, and I'm going to read to you from the quiz review. It says the following 5 questions use the following information. You travel at a constant velocity east for 4 kilometers in 2 hours, and then 7 kilometers east, also at a constant velocity for another 7 hours. Okay. Now, so on the quiz, you're going to get that prompt. It won't say the following 5 questions, but you're going to get the same sort of stuff there in those questions. So you might not use the whole thing. So it's as if you're getting 5 questions. But so anyway, we're going to look at that. So let's say that we had more of that information. Okay, now it's going to end up being the same numbers. Okay. But let's say that I had some different data, okay, that gave me distance and time. Okay, so we're just going to set up a data table, and then we're going to apply it over here to this graph, and we'll talk about Sultan. All right, so if you can see here, we start out, and at a constant velocity, we're going to go 4 kilometers in 2 hours. Okay, so I've added a point in here that you'll see which it makes constant. And then over the next 7 hours, we'll have gone another 7 kilometers. So the information that's in this review is also the same sort of thing that we're going to get in this graph. So now we're going to use this sort of stuff next week and throughout the rest of this quarter. So you need to be able to make and interpret graphs. So that's what we're going to do here. All right. So you guys, in Sultan, okay, the S stands for scale. Okay. So that we're going to have a scale on the dependent variable and the independent variable. So you guys from that slideshow, the x-axis is going to be the independent variable. It doesn't matter how long the time goes. You could be moving in any direction. So time just keeps moving on. And that's typically why this x-axis is called the independent variable, because it doesn't depend on this one. If you are walking, for example, time doesn't depend on you walking. if you want to know how far you go in a particular time. That's why we have that. So we've got the distance that we've walked and we've got the time. Okay, so that we're going to go from 0 up to 12. And in these parentheses, it's going to be kilometers. Okay, so each one of these little marks is going to be 2 kilometers. And that's what we mean by scale. Okay, so the scale on the x-axis or the horizontal axis is going to be time. Okay, and so what we're going to have here is we're going to have hours there, and that is our unit. Okay, and that brings us to the U in Sultan. Okay, so we need to have units here. We need to have units on the dependent variable, and we have units on the independent variable. So now we know what we're talking about. Okay, so now I plugged in these various points. We're going to start at 0, 0. You don't always have to start at 0, 0, but that's usually where you do start. Okay, and then we went a distance of 2 kilometers in 1 hour. There would be the data point for that. And then we went 4 kilometers in 2 hours. That's the data point. Okay. And then we kind of changed and okay, so at 6 hours, we went 4 kilometers. And at 8 hours, we went 6. And at 11 hours, we went 9. Okay, so these are all of our points. Okay. And this right here is going to be a line graph, okay, because we're connecting all the points, which makes it different than a bar graph or whatever. Okay, so now the L in Sultan is going to be labeled. So we labeled distance and we labeled time. We labeled our axes, and then we also had the units. Sometimes you can have the units at the end here. So like you could have it here. And those units could be on the actual line there, or you can have it something like parentheses like there. Okay, so that's the labeling. We're also going to have a title. So here we got distance versus time graph. Okay, you could have something like the walking graph or my hiking to Laguna, sort of thing. So you could be different titles, but you're going to have the title somewhere up there. Okay, so that is S, scale, U, units, L, labeling, T, title. So we're all we have left is A and N. So the A stands for accuracy. Okay, now I've actually measured, and if we look here, okay, that is just a little bit off. Okay, so that is not as accurate as it could be. So when you're making graphs, okay, and you have, that's why it's very often good to have graph paper, because then that gives you the X and the Y. Okay, now Mr. Calicott is making up a how-to on how you can put in data here into Google Sheets, and then you're going to plug that in, and then the computer is going to generate the graph for you, and you'll have places to put all these things as far as the labeling and the units and the scale and the title. And then when you hit enter, okay, when you go to produce the graph, okay, well, the graph is definitely going to be accurate as long as you entered your data in properly. Okay, so that's going to take care of that. And then the last one in Sultan is going to be N, and that would be for neatness. Okay, now you guys, this is fairly neat, okay, but it's not perfect. If you look at here, okay, this is kind of a little, not quite perfect there. Okay, and my writing is certainly legible, but it could, perhaps it could be better. So I could do a little bit better job in it being neat, but that's fairly neat. Okay, so what I don't want is things that are sort of illegible. Okay, So here is, you guys, here is that graph, and we've got an example of Sultan, similar to what Mr. Callicott went through. You guys, what I would like to do now is I would like to go over those kind of calculation questions that I gave you in the review, and we'll go over that. Okay, so the first question in your review is, what is the average speed from 0 to 2 hours? Okay, now it actually happens to correspond here to this graph, okay? But, and I'm gonna kind of shift this over, and I'm gonna talk about Mr. Callicott's little memory device where he had a triangle, okay? And this triangle was something like this, okay? And it had a D, and it had a V, and it had a T, okay? Or this might be an S, okay? And I believe his little analogy there was dragons fly over vipers and snakes and trolls, okay? And so in this first problem, you guys, in this first problem, we're asked for average speed. And so again, Mr. Callicott talked about, if you want to know what the equation for that is, if we cover up the S or the V for speed, then our equation is going to be distance over time, okay? So our speed is equal to distance divided by time, okay? Now we look in this problem, and we will have gone, in the first 2 hours, we will have gone 4 kilometers. All right, so that was our distance. And our time was in the first 2 hours from 0 to 2, okay? And it's actually be the final, which would be 2 minus 0, which would be 2. So we're gonna have 2 hours, and we're gonna do that calculation. 4 divided by 2 is going to give us 2. And then our units are going to be kilometers per hour, okay? So the answer to our speed, our average speed in this first question is going to be 2 kilometers per hour. Now, you guys, you might also look in this problem, it talked about being east, okay? So if we want direction, then our answer would be 2 kilometers per hour east, okay? And that is the difference, you guys, that's the difference between a scalar and a vector, okay? So if we just have 2 kilometers per hour, that is a number and a unit, but without a direction. So that would be a scalar, okay? And if we add in the direction, that would make it a vector. So if you kind of go back to the scalars and vectors sheet, that's going to be the difference, okay? All right, so that was number 1. Now, if we look, you guys, if we look on this graph here, and we're going to talk more about this next week, but if we look at this line right here, we will have gone 4 kilometers in 2 hours. And you guys probably remember from algebra that if you have a graph here and you connect the lines, that's going to be a slope. The slope is going to be rise over run. Okay, the rise is 4 kilometers, the run is 2 hours. So our slope here is going to be our average speed. Okay, so we'll talk more about that. We'll talk more about that next week. All right, you guys, let's do problem number 2 on our review. Okay, what is the average speed from 0 to 9 hours? From 0 to 9 hours. Okay, so this is, if we look, and I'm just going to show you the graph, okay? From 0 to 9 hours. Now, remember, in the first 2 hours, we went 4 kilometers, and then the next 7 hours, we went 7 kilometers, Okay, so our total distance, okay, and we want, so our average speed is again going to be distance divided by time. Okay, now our total distance was 11 kilometers and our total time was 9 hours. And we're going to go 11 divided by 9, and that's going to give us a value of 1.22. Okay, and we are going to round that to 1.2 kilometers per hour, and that's going to be our average speed. Okay, now if we said 1.2 kilometers per hour east, then that would be equal to our velocity, because velocity is a vector and speed is a scalar. Now, again, in these first few weeks, we're not going to worry so much about the difference between speed and velocity, because as long as you're going in a straight line, then speed and velocity are the same thing. Is when you start changing direction or you're changing speeds is where the difference is. So that is not to be super confusing in the beginning. We're just going to say that they're going to be the same. Okay? All right. So, you guys, there's the answer to number 1 and number 2. And because of the way it fits on this board, you guys, I'm going to erase number 1 and 2 and leave us room for the rest of the questions. So, all right, question number 3. How far would you travel from 0 to 1 hour? Okay, so problem number 3. We want to know how far, okay? So we would put our hand over the D, and our answer would be velocity times time. So distance is equal to velocity times time. Again, this could be speed. Okay, right now we're interchanging this, and you guys in that first 2 hours we were going at constant velocity, and in problem number 1 we know that we were going 2 kilometers per hour. So we're going to say 2 kilometers per hour was our time, our velocity, and our time, according to this question, is going to be 1 hour. Okay, and 2 kilometers per hour times 1 hour. Notice that these units are going to cancel each other out, and we're going to get 2 kilometers. Okay, and that would be our distance. Okay, if we said east, then that would be our displacement. Okay, again, we'll talk more about that. But for right now, we can just think of those distance and displacement being the same thing. All right, problem number 4. Okay, how far would you travel from 2 hours to 9 hours? Okay, well, in this one, if you actually just go back up and read the question, okay, it says if you traveled east at a constant velocity for 4 kilometers in 2 hours, and then another 7 kilometers in another 7 hours, okay, well, if you're going from 2 kilometers or 2 hours to 9 hours, that was 7 hours. So you can just actually read that from the question, and you had 7 kilometers. 7 kilometers. If you look at where that graph was, you started out here at 4 hours, and after 4 hours, after 2 hours, you went another 7 kilometers after another 7 hours. Okay, so that perhaps is just a little more reasoning there, just you're kind of reading it directly from the problem, okay? And problem number 5, what is your average speed? What is your average speed from 2 hours to 9 hours, okay? So again, we want speed or velocity. We're going to go distance divided by time, okay? So speed is equal to distance divided by time, okay? And so we want to go from 2 hours to 9 hours, okay? Well, after 2 hours, then we went 7 kilometers. So our distance was 7 kilometers, and our time would be 9 hours minus 2 hours. Okay, so 7 kilometers, 9 minus 2 is 7. That would give us 1 kilometer per hour would be our speed. Okay, all right. So you guys, that's problems 3, 4, and 5. Okay, so finally, let's take a look at problem 6 and 7, and then we'll pretty much be done. Okay, we'll talk a little bit more about the claim evidence and reasoning. All right, so problem number 6. Okay, a car traveling starts at the velocity at 15 kilometers per hour north, and then 5 minutes later, its velocity is 30 miles per hour north. What is the change in velocity? So remember, this delta just means change. So we want the change in velocity, which is going to be our final velocity minus our initial velocity. Okay. So if we had this delta, remember this delta means change. So we could have change in X or change in D, okay? And when we have this change, we could say X final minus X initial, or D final minus D initial. So it doesn't matter what variable it is. If we have change here, we're going to go final minus initial. Okay, so in problem number 6, our final velocity was 30 miles per hour. Miles per hour. And we're going to subtract our initial velocity, which was 15 miles per hour. Okay, 30 minus 15. So our delta V, or our delta S, would be 15 miles per hour. Okay, so that would be our change. Okay, now finally, for this review, problem number 7. So if your rate for walking is 5 kilometers per hour, how long will it take you to walk 2.5 kilometers? Okay, so we want to know how long it takes. Okay, so we want time. So if we covered up time, that would equal to distance divided by velocity. Okay, so time is equal to distance divided by velocity or speed. Okay, so our distance is 2.5 kilometers, and our velocity is 5 kilometers per hour. And now we can say 2.5 divided by 5, that's equal to 0.5, or a half. And then these kilometers mathematically are going to calculate out. And now our hours is in the bottom of the bottom, which is the denominator of the denominator. Okay, so that actually just flips up to the top, and that's going to give us our time of 0.5 hours. 0.5 hours. Okay. So that is kind of those 7 questions are going to be similar to the sort of questions you're going to see on the 2.7 quiz, which you guys are going to do this weekend. All right. Now, let me just cover. You guys have looked this week, and you've had all these assignments, and one of them was the CER, claim, evidence, and reasoning. Claim, evidence, and reasoning. So you guys started out with that assignment as saying who's the greatest singer or band, or whatever, and you guys kind of choose. You first made a claim, and then you went through and looked at section 2.2, and it talked about the evidence and then the reasoning. Okay, so maybe in a sort of a different analogy, you might have let's say 2 bags of chips. Okay, and let's talk about you guys, let's say brand X, okay, and you're going to get 6 ounces for $1.20. Okay, so brand X chips, 6 ounces for $1.20, and then you're going to get brand Y, and you're going to get 1 ounce for, let's say, $0.50, okay, or half a dollar. All right, so which chips are the cheapest? Okay, which bags are the cheapest? Okay, so I could say that brand X has the cheapest chips. Okay, so what would be my evidence? Okay, well, I can say that the cost, okay, per ounce, okay, so I've got $1.20, okay, for 6 ounces, and 1.2 divided by 6 is going to be 50 cents per ounce, right? No. 120. 1.2 divided by 6. Sorry, having a little trouble here, ladies and gentlemen. 1.2 divided by 6. 7.2. .2. Sorry. Okay, so we're going to have $0.2 per ounce. $0.2 per ounce. Okay, so there, okay, it is clearly that brand X is cheaper per ounce than brand Y. So my claim is that brand X is cheaper. My evidence is that I developed it into the cost per ounce, and $0.2 or 20 cents is cheaper than 50 cents. So that is my evidence for you to buy brand X. Well, you can make a different claim. You could say that brand Y chips are cheaper per bag, because clearly 50 cents is cheaper than $1.20. Well, if you wanted to get the most chips for your money, you would choose brand X. If you only had 50 cents, then you couldn't buy brand X, and you'd have to buy brand Y. Okay? So the reasoning, the CRE, the R in there, is what is really going to sell you. Okay, and if you looked in the in that voiceover there, the reasoning, that's really your conclusion. What out of the claim, you saw the evidence for how do you put together the evidence in a reasonable, logical sort of way to give you your conclusion. Claim, evidence, reasoning. All right. Hey, ladies and gentlemen, good luck. Hopefully this helps you. And we will see you guys at the next Zoom meeting. Take care.